Hi everyone, as promised, I wanted to show you how to do example 9, which is example 4.3 on rest of our notes here. Remember how we were working on our 6.3 notes about applications of parametric equations? So I know that we didn't get to this one, but this one's a really good one. And you remember the extra information that I sent you with, right? With the initial velocity and all that good stuff. So this kind of goes along with that. So you see that x is the initial velocity times time, and y is this because this is includes, right, in feet, right? This is the initial velocity and this is the initial height. Just look at that sheet and then you can follow along. But I want you to always put yourself in the situation of hitting a baseball. No matter what, I mean, no, even if you don't like sports, even if you've never watched baseball, you know how it's played. You hit a ball and you hit it from your height. I mean, well, a little just below your height. For example, I'm 4 feet tall, but I'm going to hit it about maybe 3 feet off the ground. Just like Kevin in this problem. Kevin hits a baseball at 3 feet above the ground with an initial speed. So we're going to highlight some information. Initial speed of 150 feet per second and an angle of 18 degrees with the horizontal. So if you can imagine what's happening, okay? So you have somebody here, wait the bat, right? Okay, there's Kevin. He's gonna hit his ball, his bat, right? And it's gonna be about 18 degrees. I know I exaggerated that 18 degrees. Of course, 18 degrees is less than that, of course, okay? And what is his goal? We want to know when he hits it at the 18 degree, given all this information here, is he going to be able to clear a 20 feet wall and a 400 feet away? So let's see what that's saying. That means when he hits this, he has to hit it 400 feet and 20 feet high up. That would make it so it's out of the park, okay? So we want to see if Kevin could do that given he hits it at 18 degrees, okay? So again, this kind of information, I know this is part of the solution, but this kind of information will be provided for you. I mean, granted, this is standard, negative 16t squared, and this is initial velocity, and this is initial height. Initial height, Kevin is hitting at 3 feet above the ground, and initial velocity is 150 feet per second, but it's sine 18 degrees. Remember, look at the formulas I gave you with the vectors, okay? Now, here's your x. Now, we're going to actually graph this onto our calculators and see if indeed this does happen, okay? Now, we're going to use parametric, of course, so I'm going to go to the calculator, okay? So allow me to show you on the calculator here. Now, we're not going to graph a function, we're going to graph a parametric. So we hit graph, edit entry, parametric. All right, now let's type it in. 150 times, and I know that I'm not on degree mode, so I'm going to go cosine, parentheses, 18, but I'm going to make sure that I put in a degree symbol there, times t. Oh no, yeah, it's time t, right? Okay. Oh, what happened? Yikes. Oh man, let's start over. Sorry about that. I'm gonna add a graph. Oh my goodness. Menu, parametric. I'm sure you're ahead of me now. That's a good thing. All right, let's do that again. 150 times. I already had this typed, but I wanted to type it with you. 18. You have to put the parentheses actually after the cosine, okay? Make sure you put a degree symbol times t. Y sub 1 was negative 16t squared. Negative 16 times t squared plus sine, 150. 150 times sine, parentheses, 18 degrees, because I'm on radian mode, times t plus initial height, which is 3 feet, okay? And you guys, think about the ball that's traveling. Like, how long do you want it to travel for, okay? I'll just leave it as 6.28, but you can even, if you want, you can do like, I don't know, like 10. I don't know, 10 seconds of the ball that travels, okay? And maybe you want to know precisely, so I'm going to go 0.05, because when I trace it, I want it to be more precise. So I'm going to graph it. Okay, right now I can't see much. So what you want to do is I want to take away my equation, and I want to go to menu, and I want to go to zoom, and I want to go to zoom's fit data, and I can see that this ball is traveling like this. But right now it's just too far away. So what I'm going to do is I'm going to go to window and zoom, and I'm going to box the part that I want to see. I want to focus there. And if you want, you could do even better, like larger. That sounds pretty good. That's the path of the ball. So what I'm going to do also is, because this is distracting to us, I'm going to hide this information from us. Hide, because this is kind of distracting us. Okay, now it looks all nice and clean. So let's answer the question. Will this ball clear a 20 feet wall, right? Will it? Well, let's trace it. Menu, let's trace, and I'm going to trace graph, okay? I'm going to trace this graph. Watch my x sub 1 and y sub 1. Remember, x sub 1 tells me how much it's traveled left to right, but in this case, only to the right, towards the 400 feet that we have to clear. And then, of course, the height we're looking for is 20 feet. Did it go over 20 feet? My ball is traveling. My draw is traveling. Whee! 1 second, 2 seconds. Wow, look at how far it's traveling. Wait a minute. Did it clear 400? Wait, it already cleared 200. I mean, it already cleared 20, right? It already cleared 20 feet on the Y, right? Oh, but I mean, is it going to reach 400? Because it has to clear 420, right? So let's see. Let's keep going. The ball is traveling. The ball is traveling. The ball is traveling. Wait, it did cross it, but look at the height. Oh, it's been 3 seconds. Now the ball is under the ground, which is impossible. That means the ball was 0 somewhere here, right? Right, somewhere right here it was a 0. But you can tell that it did not clear. It did not clear this part. So let's go back here, you guys. You guys, where were we? So look like about, okay, let's go here. At about 3 seconds, right? At about 3, oh, you know what? We could find out exactly what it was at 3 seconds. At 3 seconds, look at the screen. So I'm going to go to graph trace. Oh, sorry. Oh, whoa, what's happening here? What's happening here? Okay, I'm going to go to menu, trace, and I'm going to type in 3, enter. At 3 seconds, it was, okay, at 3 seconds, it was 427.97 feet away, right? Right? It traveled that way, but it went under negative 1.942, right? But that means the ball was under the ground. But what about when y was about 0? So let's go up a little bit. Let's go up a little bit. Okay? Let's go up a little bit. Wait. At 2.95 seconds, it was about 420, oh, sorry. It was about 420, right? Feet. And that was, the height was only 0.05. But it needs to complete both of those conditions in order for it to clear the field. So the answer is, the ball will not clear the wall. All right? So do you guys see how it's kind of done? So you can see how you can just write your parametric equation, and then you can trace the parabolic path that it's traveling. Okay. Now there is a way to actually to see if it clears both, but I'm going to show you that in class. But another thing I want to tell you is, wait, what was I going to just tell you? Oh, play around with the angles. You know how this is 18 degrees right here? You see how this is 18 degrees right here? I wonder if this was 20, what would happen? I wonder if it's 90 degrees, what would happen? What if it was 70 degrees, what would happen? Is there a magical angle that he needs to hit it at in order for it to be able to cross this 400 feet? So in order for the ball to travel 400 feet this way, but up 20 feet to hit a home run. Okay, I think there is a magical angle that you have to shoot a basketball, and maybe some of your basketball players know that. Okay, so hopefully you guys were okay with this. Let me know, and we're gonna try one more together in class. Okay, all right, have a great day. Bye.